Half a day, everyone. My name is Martin Kastner. I'm a PhD student with Iowa State University and the Ecology of Bird Loss Project. First, I'd like to introduce my co-authors, Kayla Baker, Juan Mungaray, Shane Sires, Evan Paxton, Scott Getz, Malia Nafis, and Halder Rogers. Såli are one of Guam's native bird species, and besides the population on Cocos Island, Guam Såli currently nest and roost exclusively in urban areas and on Andersen Air Force Base in Vigo in particular. Within their range, Såli fledglings continue to suffer extremely high levels of mortality. We've recorded between 75 to 95% mortality in a given year, and most of the mortality is from BTS predation. BTS in urban areas also constitute an elevated biosecurity risk because of their ability to stow away in cargo or in household goods and vehicles, and therefore be transported to other locations. Acetaminophen is an EPA-approved toxicant for the control of brown tree snakes, and it's been used along with dead mouse baits in bait stations and also through aerial delivery in the past few decades. But acetaminophen baiting of brown tree snakes has not yet been attempted in urban areas. Our attempt to control brown tree snakes in urban areas through the use of acetaminophen bait in bait tubes and using Såli fledgling survival as an indicator of the success of suppression is a new direction in brown tree snake control. This talk will focus on two main research questions. The first, will brown tree snake baiting produce a detectable increase in Såli fledgling survival? And second, will brown tree snake baiting lead to a reduction in brown tree snake caused fledgling deaths? We divided up a portion of the housing in urban areas on Andersen Air Force Base through factorial design, with exterior plots bordering forest and interior plots further away from forests, as well as high and low presumed brown tree snake density plots. We based our assumption of brown tree snake density on preliminary data from USGS visual surveys, as well as our data from radio tracking of Såli. This yielded 4 plots, and each one was split into treated and untreated areas, giving us 8 subplots. You can see those on the map, and the blue dots represent Såli nest boxes. The team at USDA deployed 50 bait tubes in each treated subplot. They deployed them on trees at least 20 meters apart as per EPA guidelines. Baits were changed every 3 to 4 days, and within plots, we alternated between small and large dead mouse bait and small and large dead chick bait, with the small baits being hatchling quail and the larger ones chicken chicks. Our team attached as many radio transmitters as possible to fledglings within the study area. In the pre-treatment phase, between November 2019 and October 2020, we deployed 62 radio transmitters. And in the post-treatment phase to date, we've now surpassed that number. We track Såli fledglings on a daily basis until they're 15 days old, and then 3 times a week until they're a month old. We look for survival, but if we confirm mortality, then we try as best we can to identify the source of the mortality. And most of the time, the source is clear, but every now and again, we do come up with a mystery. So back to the bait tubes. Take rate in the high brown tree snake density plots have been significantly higher than those in the low density plots. You can see that in the graph on the upper right, with the high density plots shown by the top two lines, and the low density plots, the lower two lines. That result is not all that surprising, but more surprising has been that the take of mouse baits has been significantly higher than those of chick baits. You can see that in the graphic on the lower right, with the mouse baits represented in the bluish lines on the left of the bar graphs. And although that you might think that demonstrates a preference, what the teams have noticed are that the mouse baits last a lot longer in the environments, whereas the bird baits tend to disintegrate faster. And we can't be sure that some of the snakes that took bird baits would also have taken a mouse bait. To date, there have been 269 bait takes overall. Applying a 20% non-target adjustment, which is what we documented in phase 1 of the project, that's equivalent to roughly 215 snakes removed from the project area. We haven't documented an obvious change in Såli fledgling survival in the control plots. Looking at pre versus post-treatment survival within the treated area, the proportion survival after 3 weeks looks about the same. We've continued to document high rates of mortality from BTS, and in the treatment areas, especially cats and a number of starvation deaths throughout the dry season. It may be noteworthy that we haven't documented the large drops in survival that were seen in some of the untreated areas within the treated areas from the pre-treatment phase to the post-treatment phase. In the pre-treatment phase, roughly 50% of the mortality across all plots was caused by BTS, with the rest being made up of cat predation and other sources of mortality. Post-treatment, the proportions have stayed about the same in untreated areas, whereas in treated areas, the proportion of BTS caused deaths have dropped by about half. Most of the plots in the treated areas have seen a large drop in proportion BTS caused mortality, besides the high interior subplot, which has seen an increase, but has also seen an increase in survival. And it's a plot where we haven't had the opportunity to tag many birds overall. In the pre-treatment phase, besides the low interior plot, we had some BTS-caused deaths, which are depicted by the yellow triangles in each of the treatment subplots. Whereas in the post-treatment phase, the only treated subplot where we've seen BTS-caused deaths has been the high exterior plot. So in summary, we haven't detected an increase in fledgling survival throughout the treatment phase of the project. However, we're currently coming into the time of year where Såli nesting and fledgling is at its highest. And so we may yet document a signal of increased survival. Brown tree snake caused deaths have decreased within the plots, which is a promising sign. That said, we have seen some continued brown tree snake caused mortality and signs of BTS, such as sheds, particularly in the high brown tree snake density areas. Note also that the largest BTS may not be killed with a single dose of toxicant, although we have seen some positive signs in that regard from radiotransmitted snakes. cats remain a major cause of mortality within the study area. And if managers want to increase Såli fledgling survival or are thinking about reintroduction of other species, then it would be very important to target cats as well. We've shown that suppression of BTS through the deployment of bait tubes may indeed be possible, even in a relatively bird-rich area on Guam, where we weren't sure if brown tree snakes would actually take any bait with a lot of prey available. Therefore, it is a potentially useful tool for localized suppression in areas such as urban areas where there may still be small pockets of BTS within the landscape. Bait tubes are useful in scenarios where aerial delivery isn't an option or for spot treatments after aerial delivery, and they can be used alone or in combination with other methods such as traps or visual searching. That removal of brown tree snakes could be the difference between population decline, stability, or growth for extant species such as Såli or swiftlets, or reintroduced bird species in the future. Just as with any suppression method, it does need to be maintained. And so an open question is, how long would the signal of decreased brown tree snake deaths continue if and when bait application stops? With that, I'd like to thank our DoD funders and partners, as well as the fantastic crews from USDA, Iowa State, and USGS. I'm happy to take any questions.